Okay, your homework last time was 708, 1 through 8. Are there any questions from your homework last time on page 708, numbers 1 through 8? Jared? Is it the domain and range you have questions on, or the graphing? Okay, so number 4, he asked for. It says f of x equals, well, that's the same as y equals. Okay, so you're able to graph it? Because you have to graph it first before you know domain and range. Did you do an xy table? Okay, so for the x's every time, okay, Annabelle, you need a new seat. Annabelle, come sit right here in that blue chair in the 3rd row, please. You see I'm in the middle of a conversation? I will help you when I'm done. Please move. Okay, Tristan? As long as it's flat on your desk and you don't go to anything else. I have to be able to see it. Okay, so every time you graph, you need to do an xy table. We always are going to be using, for quadratics, the x's from -2 to -3 to +3. Thanks for moving, Annabelle. Okay, and then you plug them in one by one. Jared, why don't you tell us what you got?
Well, that's part of the
Oh, I thought you said it was a domain and range. Okay, so I guess we'll work it out. Okay, to find out the y values, you plug them in. First, we do 2/3 times whatever the x was, squared. Wherever there's an x, I put parentheses, because that's the place we plug in. So either, right now, you should have your book out, and you should be working with us, or checking you're working your book. If you don't have your book, you should have a piece of paper out. Okay, open up paper. We're giving you a free homework problem. I'm pretty sure the assignment was 8 problems, and we did 3 of them together in class. So here's the 4th one together in class, which means you only have 4 more to do. So I don't know why you wouldn't write it down. Please pull out a piece of paper. Okay, the first x we plug in is -3. We're on page 708. Okay, with please excuse my dear Aunt Sally. What do we do first? It's actually exponents because there's nothing in the parentheses to do, right? You do check for parentheses, but after that we do exponents. So first we do -3 squared. It's not negative. It is +9. Okay, so that represents 9/1. I wrote it this way because of this fraction. So when we times fractions, we time straight across. Unlike the problem we just did at the beginning of class where we added and subtracted fractions, you don't have to have a common denominator to multiply. So 2 times 9 is 18. 3 times 1 is 3. And what does this become, Cynthia? 18 divided by 3? Sorry, I've been talking all day, my throat's dry. 6, great. So that's our first y value. Okay, now we'll do it again, but this time we plug in -2. Okay, Carlos, with the exponent, what do we get here? -2 squared, first of all. 4, good. So we have 2/3. I'm going to write that as 4/1. Okay, so we can see that we do 2 times 4, which is 8, and 3 times 1, which is 3. Now, unfortunately, this one doesn't divide as nicely as the last one. How many 3s are there in 8? 2, remainder what? 2, remainder 2 out of 3. So it's 2 2/3. We keep going until we see a repeat on the y's. So far we haven't repeated. So we keep going. 2/3 times -1 squared. Okay, Gerardo, what do we get here? with the exponents. What is negative 1 squared? No? No? Squaring means negative 1 times negative 1. Positive 1. And 2/3 times positive 1 is just 2/3. Any questions yet, Jared? Okay, next we do 0. 2/3 plug in the 0. Okay, Valeria, we need to do exponents first. What is 0 squared? And Valeria, 2/3 times the 0? 0. Any questions so far? Okay, next one. 2/3 times 1 squared. Okay, Griffin. First we do exponents. 1, good. And 2/3 times 1, Griffin, is 2/3. Finally, we have the first repeat. You see that? We got 2/3 and 2/3, which means the one in between is the vertex. Okay, so if these two are hugging the 0, so they match, then the next two above and below match. So we just spread out. So 2 and 2/3 here will match positive 2's y value, which is also 2 and 2/3. So those match. And then we spread out. The next two will match. Positive 3 and negative 3 are both 6. Does that make sense? Because of symmetry. Quadratics are symmetric around the vertex. Okay, so then you can graph it. Can I erase this work? Does anyone need the work area? Okay, you were given in your book a graph. You just have to put the axes on. So take a look at our x. It goes from negative 3 to positive 3. So we have both positives and negatives. And look at the y's. What's the lowest y value? 0. And the highest y value? 6. So there are no negatives. So we don't have to draw negatives. We can take and do an upside down T. You make the graph, you manipulate the graph to match what you need it to be. If we don't have any y's that are negative, we don't need to use the negative half of the graph. Make sure you draw arrows on both ends and label x and y. Okay, and yours is already marked with the boxes, so I'm just going to try to evenly space. And then up to 6. Make sure you label the numbers. I like to make my 5 a little bit larger so that every fifth one is larger, so I don't have to keep recounting lines. Okay, and then you just need to go plot those points. So negative 3, 6 is, we go left, negative 3, up 6. But where is negative 2 and 2/3? Where is 2/3 at? Yep, so right between, you can divide between 2 and 3 into 3 sections and go up 2 and 2/3. It's just below positive 3. Negative 1 and 2/3. 2/3 is between 0 and 1, right here. Any questions on how we graph the 2/3? 0, 0, and then we can use symmetry, because these ones should be right across from each other. Like that. And what shape goes through them? A U. Does anyone remember the vocabulary word for that? Good job. Parabola. And at the end of the U, it does keep going up and up and up and spreading out left and right. So we need arrows. Okay. I will help you with one of the domain and ranges. You're supposed to do it 3 different ways. We learned 3 notations. We learned interval notation, we learned set notation, and then we learned inequality notation, actually in that order. So which one? Look at your book from, we did number 3. We did all 3 of those notations. We did interval, set, and inequality. Which one would you like help with? No, I said I'd do one. Set notation? Okay, that's a good one. That's what the other classes chose as well. Set notation. For domain, remember domain is the spread of the x's, so that's why on my domain I put a little sub x. So I remember domain is related to the x-axis. And the range, r sub y, is related to the y-axis, because the range is looking vertically, top to bottom, the spread vertically. Okay, so with the domain, we're looking along the x-axis. And as long as there's points above or below the x-axis, then we're still going to the left. So how far left does this graph go because of the arrows? It goes left, left, left forever, right? So it's to negative infinity. And then it goes right, right, right to positive infinity. So we write that with a set. Set is the squiggly brace. This brace has words that goes with it. It's called the set of all. The set of all, what letter? The set of all x's, because domain is relative to the x. Now how do we write such that? Yeah, good job. The line. Such that. The set of all x's such that x is, if we're going from negative infinity to positive infinity, is that all of them, or does it like skip numbers? Oh, there's the word real numbers. So we do a C with a line in the middle, real numbers, which is a capital R with a double slash. So this is red. The set of all x's such that x is in the real numbers. The set of all x's such that x is in the real numbers. Okay? The next one changes. It's the set of all, what letter? Okay, she's right there. The set of all y's such that what? Is y in the real numbers, negative infinity to positive infinity? No, we have to look at how low does the graph go. The graph goes down to 0, and then it goes up to positive infinity. So we say y is less than infinity? Greater than or equal to, what's the lowest number? 0. So again, that's red. The set of all y's such that y is greater than or equal to 0. So it starts at 0, and then the graph's going to go up through all the numbers greater than or equal to 0. Okay, and you are supposed to then do the same domain and range, but in interval notation and in inequality notation.